All right, this is unit 6.2, exponential functions. So exponential functions are functions in which data is rapidly increasing or decreasing according to a constant ratio, which you'll see in your equation as b. Here's the equation. Y equals a times the base to the x minus h power plus k. All of these things should look a bit familiar. So when you graph these, they're a smooth curve, so no vertex. So let's talk about the a, h, and k. They have the same impact on the function as we were talking about with absolute value functions. So these things should seem really familiar to you. So again, the a is a reflection. If you have a negative sign, it is a stretch when a is greater than 1, sorry. And then a compression when a is less than 1. Okay, the h is a shift left or right, opposite of the sign. And the k is a shift up or down. It's with the sign. So it's a shift up or down. So these things haven't changed. Okay, so there is one more word that we need to talk about, and I don't think I wrote it down anywhere. It's asymptote. Okay, that's a line that the function gets closer and closer and closer to, but never touches. So again, that's a line that the function infinitely approaches, but never touches. So you can find the equation of that line by finding k in your equation. So that is y is equal to k, kind of like we had with the axis of symmetry, but this is y because it is a horizontal line. All right, so when we graph them, you're always going to use this. And this is the parent, so we're not going to have much change. And remember, this is your base. Okay, B is the base. Okay, so let's fill out the center first. So we're going to, y here is 1 over the base, so y is 1/3, then is 1, and then is b, which is 3. So if this wasn't the parent, any h would impact the x, so h in the equation impacts the x value, and the a and the k in the equation impact the y values. And you'll see after the parent, you'll see what happens. So here, because this is a parent, there is no a, there is no h, and there is no k. So these are going to stay the same. So let's plot the points. I have -1, 1/3, and I have 0, 1, and 1, 3. So let's figure out what our asymptote is. It's k, right? There's no k. So it's y equals 0, which means, let me get another color here, that here's your asymptote. This graph is going to go like this. It's going to approach that asymptote, that 0 line, but it's never going to touch it. So it's going to go right on top but never get there. Okay, so your asymptote is y equals 0. The domain for all of these is negative, infinity, infinity. Remember, that's left to right. The range, you're going to get almost to 0. That's why there's a parentheses. Never touch it, approach it, and infinity. So that's why there's not a bracket there. I want to add a couple more things here. Let's add y-intercept. Where does it cross the y? So that's right here at 0, 1. Sometimes that's easier to figure out than others, and you'll see as we progress. And then let's add a translation section. So because this is the parent, there's none. No translations because this is the parent. Okay, let's move on to number 2. All right, so here our base, or b, is 4. So let's fill in the y. So 1 over the base, 1 and 4. Remember, the h affects the x, and the a and k affect the y. So where's your h? Well, your h is up here. Nothing's happening, so none. That means your x stays the same. Your x value stays the same. So let's just copy that over. So this is still -1, this is still 0, this is 1. But we do have an a, okay? It's multiplying, right? So we are going to multiply everything, every y coordinate by 2. So 1/4 times 2 is 1/8. 1 times 2 is 2. 4 times 2 is 8. So our new points here are -1 and 1/8, 0, 2, 1, 8. Okay, so let's plot those. So I have -1 and 1/8 super close. Then I have 0, 2, and 1, 8. Super steep. Let me get that back. Okay, so before we draw the line, let's figure out what our asymptote is. Is there a k? No, there's no k. So again, my asymptote is 0. So we're going to come super close to that, but never touch it. And man, that's steeper than the last one. Okay, so the domain again is negative infinity, infinity. Range comes pretty close to that 0, but never touches it, so that's a parentheses, to infinity. Again, let's add these other two things. Let's do our y-intercept, which is 2, or 0, 2. And the translations, we have an a, and it's greater than 1, so it's stretched by a factor of 2. All right, moving right along. Okay, number 3. So remember, the h is over here, a and the k are over here. Right? So let's figure out our y's. Our base is 2. So I have 1 over 2, 1 and 2. So we do have an h. So it has to be the opposite of h, so we're going to add 3 over here. So -1 plus 3 is 2, 0 plus 3 is 3, 1 plus 3 is 4. So that's my new x. Over here, we have a -2, so we're going to multiply by -2 for each one of these. So 1/2 times -2 is 1. 1 times -2 is -2. This is negative, sorry, -1. And then 2 times -2 is -4. Let's figure out what our asymptote is. Again, there's no k, so we're still at that y equals 0. Okay, so let's plot 2, -1. Let's plot 3, -2. And then the last one is 4, negative 4. So our asymptote is 0. So going to get as close as we can to that. So this one is reflected upside down because we have that negative sign right over the x-axis. Okay, so let's start with the domain. Again, this is negative infinity, infinity, because we're going left to right. And that's going on forever, left to right. Range, we're going to start with the lowest. So we have negative infinity, 0. And I told you to add the y-intercept. So this time it's a little trickier. So what you want to do is you want to plug in 0 in for x to get the y-intercept. So I'm going to take negative 2 times 2 to the 0 minus 3 power, which is the negative third power, which gives me 2 to the negative third power is 1 over 2 to the third power, or 1/8. So negative 2 times 1/8 is negative 1/4. So that'll be negative 1/4. That's your y-intercept. So again, to get your y-intercept, you plug in 0 for x, and that's only when it's fractional and you can't see that it's a whole number. And what else did I say we need? Transformations. Transformations. I'm going to add that. So that negative sign, it's a reflection over the x-axis. The 2 gives us a stretch. And that negative 3 is a shift right of 3. All right, so I'm going to stop this right here so I don't run out of time, and then you can continue in the next part.